Hello, everyone, and welcome to our final edition of our Big Data and AI Toronto 2020 follow-up series. We have an excellent lineup today. So our first speakers will be from Zitain. We have the CTO of Zitain, Patrick Saint-Amand. We also have the senior data scientist, Dr. Mina Amiri. Following their presentation, we will have the senior solutions consultant for Denodo, Paul Ferron. Now, if you do have any questions for any of the speakers, there is a Q&A button. You can please put your questions in there, and then we will leave time after the presentations for those questions. And like I said, I'd like to introduce our first speakers from Z10. Patrick, Dr. Miri, please take it away.
Let me just share my screen. So, hi everyone. So I'm happy to be here. I'll start this here. So the title today is Why Seeing is Believing and Understanding. It's about navigating complex neural networks and to accelerate discovery by reducing the guesswork. And one of the main underlying theme behind all this will be QA. And I'll be talking about this a little bit more in what follows. So we're a small team. Well, I guess the team has grown pretty. I guess it's grown a lot. So we're based in Montreal. Software developers, data scientists, help HPC compute and simulation and 3D rendering. So we're a pretty complete team, and we all have that like very highly visual underlying. So whatever we do, it needs to be visual. And we're all about quality assurance for machine learning. And I'll be explaining a little bit more because we don't always see those words together. And I'll be presenting the tools that we use for this. And also, Mina will be presenting some QA use cases where we found like a really deep insight on how to improve the machine learning models. So we have multiple clients: Rheinmetall, Thales, Presagis, Blue Wave AI, and others that I didn't put here, and some of them I can't actually put them here. We also have here's a few partners, government and local, and yeah, and so now basically what I'll be talking in a few minutes is about quality assurance and quality control for machine learning. And QA is about prevention. And for us, in the case of machine learning, it's about quick access to the model internal data so that you can debug, optimize, and gain trust in your model. This is something that goes on continuously. So you prepare your model, you code your model, use whatever framework you use, and then you look at the model in Zitain, and so that you can go inspect everything inside the model. This makes the models really understandable, and also you understand how the data interacts with the model themselves, because just data is not enough, just a model is not enough. You need to see both interact together to really get those insights and understand what is happening. And also what's important is that you're able to that it's understandable and you can engage multiple stakeholders. So this helps to get a product, in this case, a machine learning model and solution that is more, I guess, high quality. And the second phase is about detection. So it can be about testing, having a human in the loop, monitoring real-time data and models in production. And so this is the second part I'll be presenting. So our tool can do both, and you can use it in different moment in a project. So to be able to get this tool, because just looking at the input and output is not enough, basically you need to open the AI black box. And this is like when we started looking into like very, very small with microscope and looking into doing brain imaging. Basically, it opens a new way to look at things and understand those complex systems. So now that's what we do with the tool that I'll be showing a little bit later. So it allows you to really dive into the model. Here in this case, it's images, but images are made of pixels, which are made of data. So it can be also an NLP model, just it can be multiple layers, fully connected layers. Doesn't need to be images, but this is a good example of what is happening inside the model, because the data comes in to the left and is transformed as it goes through the model. We've released a free Zetane viewer so that people can dive into a model and get the experience of looking into it. So we have a few curated model, and we can also open Onyx files. This is part of a large consortium. So Onyx is a large consortium including many companies, IBM, Microsoft, Sony, and so on. And it's about an open neural network exchange format. And so that it's an open standard so that whatever you build in one framework can be exchanged to another framework. So we're part of that consortium, and we're following this really closely. Our Pro version is a little bit more extensive. I'd say much more extensive. You have a Python API. So that means that all the Python code you write, whether it's in Keras, PyTorch, or Onyx runtime, you can project your model in the Zetane space so that you can inspect it. And also what you can do compared to the free viewer is that you can load your own input so that you can really inspect your own data through these models. And you have access to explainable AI and so on. And I would say usually Zetane Pro, and mostly what we'll be following is we also act as, it's not just a tool, but we also offer AI services for integration within your QA pipeline. So I'll give so for this, I think the best is to give an example of what the tool is and what you can see. And I hope this will probably bring a few questions for everyone. So I'll start with a very classic one, which is a good old MNIST, which is a classification of digits, handwritten digits. So here you have the input, and the model this is the model architecture, and the data flows from left to right. And as it flows through each of those nodes, it's transformed. Usually what is inside, we don't see it. It's not easy to access. But in our case, we can access everything about it. And you can even see what it looks as data. So in this case, you have access even to the numbers. And here, maybe it's difficult on your screen, but you even see the 4, but only written in numbers. So at each part, you can access the model and make, I would say, really surprising discovery. And Mina will kind of demonstrate that part later. You also have a way to access the distribution of the values. And for example, for this one, I can see that hasn't been trained a lot because we don't have a nice bell curve here. So there's different things that we can get for insight from insight for your quality assurance. And so I'll go to and so there's a few things you can do. I presented very quickly in the software itself, and you have access to the values themselves, each tensors, which are the components of the models. And so this is an example for satellite imagery. So it's not just MNIST, but these images are very high resolution. So you can also do it for high resolution, and that's the reason why specialists in 3D rendering and high performance computing were able to do this on the fly. So when you click, it happens right away. And so the way it works is that you can work on your model, and then you can exchange Zetane files, or you can exchange the model for everyone to see what you're doing and what you're working on. And usually what we've realized is that usually you train your model, you design your model, you train your model. Usually you would look at some of the numerical metrics, and then you'd get some intuition, you decide to guess, or you just decide like that's good enough, I don't know what to do, and then you would adjust your model. But there's a better workflow, which is you train your model, but then you look at the metrics, but you also look at how the data is interacting with the model. And we've realized that it gives much deeper insights, and it allows you to make like really decisive strategies on how to improve it. So instead of spending days doing guesswork, you really can figure it out like in 5 minutes what's happening, because you see it, you can access it really quickly. And that's more like the second phase where it's about quality control. For quality control, you need, of course, testing, but also when you're deploying your model, you need for operators to monitor not only the data coming in and the data coming out, but you also need to monitor the model all at the same time. So we've created with our clients multiple monitoring dashboards for AI and the solution. And what we make sure of doing is that we present the data in its natural way. We don't try to fit 3D data into something two-dimensional because we're a 3D engine, so we can present it as it is. So that's for this part. And maybe I'll just tell you about one use case before going to Amina's part. And so it's about an autonomous train use case. And we've realized when we trained the model, when the model was trained from our clients, that the train was detecting a gigantic boulder and it was deciding to stop. It was detecting an obstacle, but the reality was that it wasn't stopping for the boulder, which is kind of scary because we've realized that nothing was passing in one of the layer inside the model. The only thing that was really seen by the model was a small little circle here, which was the tunnel. So the train was stopping because of the tunnel. The reason is that we have never added images of tunnels saying these are non-obstacles. So this could have been pretty dramatic. And this is just a very kind of general overview of kind of intuition you get. And Mina will jump into more technical aspect. So, and also for if you're in production, you can keep these inputs that are problematic and you can inspect them after in the software. So yeah, so I'm looking at the time. I'm gonna give the presentation to Mina. And also feel free to ask some questions. We'll have time at the end. So I'll be monitoring the public chat.
Thank you. Hi, everyone. So I'm going to present some examples of how visualization can help in improving the model's performance. And I group them in three categories, how visualization can help in data monitoring, in network architecture design, and in internal tensor inspection. All the examples I'm going to talk about are in the segmentation task. So I just wanted to briefly discuss what segmentation means. So in segmentation, the goal is to assign a label to each individual pixel, and it's like a classification for each individual pixel. And we have two main groups of segmentation, or two main types of segmentation. One of them, which I mainly talk about, is semantic segmentation, when we don't care about the different instances of one subject or one object in the image. So in this case, all the people are called in one group, and the background is another group or another label. But in instance segmentation, we have different labels for different numbers of objects in the image. For example, in this case, we have 5 different labels for each person and one label for the background. And to evaluate the segmentation, the easiest way is to calculate the pixel accuracy, but we have more complicated indexes such as Jacquard and DICE. And I don't go into the details, but just to remember that the DICE can be between 0 and 1, and also Jacquard index. And when we have when the DICE is 1, it means that we have a perfect segmentation, and the ground truth mask and the segmented mask are overlapping completely. So the first aspect is the data. We all know that in deep learning, data is super important. We need to make sure that we are feeding the network the correct data, because the network is learning what it sees. So we need to make sure that the pre-processing is done correctly, we have normalized the data correctly, and so on. And I'm going to present one example from one of our projects. We were trying to segment lines in the X-ray data, and we had very good results. It was like state-of-the-art results, and we were very happy with the results. But then we were curious to see inside the network, and we realized that there's a strong activation at the corner of the images, and we could see this pattern in all the images. And we realized that this is because of this white tag, which was used for anonymization of the data. So we try to remove this tag from the data and clean the data and retrain the network, and we were able to improve the segmentation by 1%. So you can see that the DICE score was already good, but we could improve it by 1 more person. And in the data, you can see that we don't see that strong activation at the top anymore, and the histogram is more wide when we clean the data. The second aspect is the network architecture. So when we are designing a network, we want to make sure that all the layers are connected the way we want. And we usually suffer from the copy paste issues when we copy one layer of the neural network and we forget to change all the inputs or output. And when we have a more complicated network with escape connections, with different activation functions, with batch normalization, etc., we need to make sure that the network that we are implementing is the same thing as we have on mind. So this is one example that we can see the overall structure of a unit in the Z-taining gene. And as you can see the U structure, and this network is a good network for segmentation of medical images. And if we zoom more, we can see the connections between different layers. We can see the activation functions for each layer and the batch normalization. And if we even more zoom, we can have access to all the biases and weights and the input and output of each individual layer, and we can analyze the statistical properties of each tensor in the network. So this is another example. When we want to verify the network architecture, what we usually do is to draw the network on a piece of paper and try to implement the network step by step. But by Z-Tain, we can see the connections very clearly and make sure that the design is correct, and we have more confidence in design. And the last thing is the how visualization can help to inspect internal tensors. And as I mentioned, we have access to the feature maps and the filters, inputs and outputs of all layers, and also the statistical parameters of the tensors. So this is another example when we were trying to segment the COVID-19 lesions on the lung CT images, and the network wasn't performing very well. And we inspect the internal tensors, and we realized that this branch of the network was not passing the data, and all the neurons were dead. So basically, we couldn't find this issue without this visualization. But after that, we realized that we need to normalize the data at each layer, and we use batch normalization, and we could improve the passing of the data, and we could improve the performance of the model. And another example is when we wanted to try to segment the tumors in breast data, in the ultrasound data, and we analyzed the error, and we didn't have good results in some patients in some images. But when we looked at the histogram of the last layer, we realized that when we don't have good results, we have a broader histogram, and when we have good results, the histogram is very steep. So based on this observation, we developed an adaptive thresholding, and we could improve. Okay, it was a post-processing step, and we could improve the DICE score in the images with poor segmentation. So here's an example. This is the ground truth. This is before using the adaptive thresholding, and this is after using the adaptive thresholding. So I guess my time is up. I don't go through this example, and just, yeah, thank you.
Yeah.
Thank you very much.
Yeah, thank you for being here. And if you have a question, you can maybe ask maybe half of one, and otherwise you can reach out to me on LinkedIn, and then I'll be able to answer your questions through LinkedIn. So that's yeah.
Thank you very much for your presentation. We do have a few questions.
Mhm.
So the first question from the audience was, what type of companies or industries can benefit from the Z10 solution?
Yeah, I would say any company where QA and QC is important. So critical. Well, when you're deploying models that are mission critical, which is things that involves sometimes a lot of money or people's lives, I would say it's you need to have a solution that allows you to really verify and pass through all the steps, so that you can be confident of how your model will behave. And yeah, so there's more to it, because you also have to test your models in different environments. You also have to send different types of data to be able to inspect what's happening. So some of them needs a very more precise. You go deeper on into it, and others it's during the process, like Mina did. It brings it to a certain level, and after this, you need to really push your model much further to be able to deploy something safe. Yeah.
Perfect. Second question is from the public chat. What is the difference between layers?
Oh, okay. So each layer is an operator. So we have the inputs coming in. In this case, it was an image. But at every layer, at every operator, it changes those values until you get to the end, and it gives the proper output. So each square that you saw is a transformation of the initial data, and it's a little bit like a signal that passes through a network. It's exactly that.
Okay. And then the last question I see is, can you give any advice on best practices to avoid or reduce bias in any given data set?
Okay. Mina, do you want to?
Yeah. So that's a very good question, and having bias in the data set is like a general problem in deep learning applications. I think I haven't read about it in details, but I think the main approach could be to make sure that the data set that is used for training is not biased. So we can have a larger data set, but that includes more data or more markers who to validate the accuracy of the initial data that we are using for training. That could be like one important step in reducing the bias.
Yeah, and I'd say like there's your data set needs to be well balanced, and for this there's different sampling method, but also you need to also to check how, I would say, like it's how biased it is as it passes through the models. Because when you're looking inside the model, you'll see certain patterns coming up, and your data might look really good from the outside view at the beginning, but as it goes through the model will pick up certain things. So basically, you need to look at the inside model bias, which is another kind of level, and that can only be done by really analyzing whether by code or visually certain of those data as it passes as they pass through the model. So yeah, so I would extend this bias to input, but also to the internals, which is coming up as a serious issue.
Perfect. Patrick, Dr. Miri, that's all the questions we have for you guys. Thank you again for participating today. And thank you again.
Yeah.
Our next speaker is going to be Paul Fearon from Denodo. He is the Senior Solutions Consultant. Paul, welcome, and
Hi, guys.
ready? Please go
Sure.
ahead.
Do you want me to turn my camera on? I'm just not as good looking as those last two people, but
You don't have to if you don't want to.
sure. I think in the spirit of sharing and caring, I'll introduce myself to everybody. Hi, everybody. My name is Paul Fearon. I am a senior solutions consultant at Denodo, and I'm going to spend 20 minutes with you, kind of just introducing you to modern data virtualization and how that looks from a Denodo perspective. That's me. That's my picture. As you can see, my hair's grown a lot. Let's move on to the next slide. Let's just talk about the agenda. Okay, so not going to spend too much on the challenges of data management because my assumption is everybody knows what their challenges are. So I don't want to kind of educate you on something you're probably an expert at. But we're going to talk about some of the challenges in data management. Then we're going to look at what is modern data virtualization and how does that work. And why you would want to use data virtualization, the benefits, what's so cool about it, and then we'll open up for questions. And also feel free to submit your questions anywhere through the presentation. I'll try my best to be able to juggle them. Okay, so let's go into the challenges of data management. So, things get more complex, and that includes the users, right? And I think that's a key point. Expectations of data have grown exponentially over the last few years, especially we've all heard, that, data is the new gold or the new oil or whatever commodity they want to align it with. But also, digital transformation is a big deal across multiple industries, and that involves people, right? So we have more savvy users who have greater expectations. New roles like data scientists. I would argue 20 years ago there probably weren't that many, but now it's a very important role in an organization, and this leads to users needing more autonomy, needing to be able to get to the data and do what they want with it, not wait for IT to deliver something that IT kind of think they need based on maybe lots of meetings and a very, very long process. So make them self-sufficient. Let's try some self-service initiatives, but sometimes they can be a little bit complex or costly. We talk about, we've spent like a year or two building this fantastic data warehouse, and now, a specific business unit says, yeah, it's great, but I need the data looking like this for my particular business problem. There you go. You got another little project, time and money. Sorry, I just my screen just stopped. Time and money to create new data marts. It's a challenge, and again, the more data you replicate throughout your organization, the more challenges you have with integrity and governance. One that we're all aware of is regulations, and there's going to be more. My mind casts back to solar last year, and just the knee-jerk reaction that governments will have to infringements like that normally lead to more regulations. It's not going to get easier. We all know about GDPR. Data governance tools help, but because they're detached from the kind of integration platform, they can become out of sync very, very quickly. And of course, it goes without saying, the complexity of your data management landscape has changed exponentially. Many years ago, when I was a young boy, it was all about data warehouses, right? You create your data warehouse. That's the be all and end all for any analytics problems within the organization. Yet you skip forward a few more years, and now we're talking about data lakes and data lake houses. It's become more complex again because there is much more out there, and there's more demand for more meaningful data. Right? I need to understand, some semantic analytics from, my customers' social media profiles. These are all new needs and new requirements that add to the challenges. So, with the challenges splash laid out, what is data virtualization? How's that going to help? Well, Gartner always loved to do it for us. And here's a nice little quote. I won't dwell too much, but basically think of virtualization as a way of creating layers of abstraction to bring data to a business meaning or a level of usefulness for consumption by general analytics users or data service users or data scientists or maybe GraphQL or in an EAI situation. This supports a number of different use cases. So what is it from a Denodo perspective? We kind of have this 3C paradigm. The first C being connect to all of your disparate data sources. We go from very structured, obviously, to the less structured data sources. We want to present all of those data sources in a standard view to the combine part, which is where we start to model data to bring these meaningful views. That means joining information from sales for different regions, so you get this one unified view of sales across all of your business entities. It could mean creating aggregates, pre-aggregated kind of views, so that pressure is taken away from the analytics tool. Creating new fields, modified fields, cleaning data to a certain extent. All of this happens in the combine stage. And then when we get to the consume stage, what we're really caring about is making sure those virtualized informational assets that we've created that now have real business meanings, business semantics built into these metadata views, that we want as many different types of consumption patterns to be supported, right? So obviously the two main ones are data services, RESTful services, and SQL-based access. And we do support things like ArcGIS. We support things like GraphQL, so you don't have to create as many data services, and these data services that you create become more flexible. And we're always trying to make sure we stay in line with kind of common consumption patterns to make sure that we can serve as many people within your organization as possible. So what does that look like? This is kind of what it looks like. And forgive the slide, it was supposed to be animated, but I feel it doesn't need to, it doesn't want to animate itself. But here, that mess there is combine, consume, connect, combine, and consume. So if we talk about combine, if you see all of these base views, what we talk about, the red box in the middle, imagine that's Denodo. At the very bottom of the base box, the red box, you've got these base views. These views are Denodo representations of all of these different types of data sources. So what we do is we create a standard way to access, a SQL-like way to access all of these data sources, regardless of what the source is, right? Once we've created all these base views, then we can start to do things like create joined and derive views or joins or unions. We can project views to kind of have different meanings, to have different formats. We can enrich the metadata to make it more semantically meaningful to the business users, create new fields, apply security, all at this level. And then of course the top point is the consumption views, the views that we want to expose to the different types of consumers. And as you can see, we support a lot of SQL-based type access, but also data as a service. But also just as important is the data catalog, because discovery is key, especially if you're talking about a large organization in multiple silos. You want to be able to find meaningful data assets within your organization. Not only that, you want a data catalog that supports some form of collaboration, right? Remember, digital transformation is 50% human. So you've got to bring the humans along the journey, right? So you've got to give them tools that allow them to get to the data and be able to look at the data in a way that's meaningful to them. And data catalog really does help that. And add in things like smart tagging and categorization, and actually ratings by users to rate a particular data source, all help when it comes to collaborating and kind of understanding quality of data within your organization. So that's how the platform works. Let's just drill down real quick into why. I like to start here to talk about some of the use cases we support. We've kind of grouped them in under consumption, governance, manipulation, access, and storage and management. Consumption, obviously, Agile BI. Self-service is very important. Not just here's a tool that you can build your own reports on, but here's a tool that you can actually meld your metadata to make your reports more effective. Like, so for instance, we can do aggregation, we can do some of the number crunching at the denoder end, so it makes the reporting side a little bit more performant and less focused on crunching the numbers. And again, because we do it at the access point, it allows us to make sure that integrity is shared across all different types of consumers. M&A is another big use case. One of the things that people use virtualization for is to create their abstraction layer, so we shield the clients from the fact that the data has moved from Oracle Exadata out to Snowflake. Where governance is key. Again, we can now govern access to all of these data resources. We can secure them right down to a granular level, and kind of manage how people use the data, but also look and kind of audit almost how people can use the data. And I won't spend time on data storage and management. One of the things I do like is the APIfication. If you ever look at one of our demonstrations, it's so easy to create a data service with our tool set, and I think that's a very, very powerful capability. So there are 6 capabilities of data virtualization I think are key and worth highlighting. Data abstraction, zero replication, real-time information, self-service, centralized data and metadata, and location agnosticism. Data abstraction, won't spend too much time on that because we did talk about that before, but data abstraction makes things easy for everybody. It makes it easy for the business because now I don't care about where the data is or how it lives or, how do I get there? The security protocols, I just go through this one single access point, and that works out how that information is federated and what security concerns they should have. From an IT perspective, it makes life a little bit flexible for them at the bottom because now they've created this abstraction now that means they can plug things out and plug things in. They can have that data set that's sales split between, information that's on-prem and maybe historical information in the cloud. Zero replication, zero relocation. That's the key for data virtualization. The idea is we get the data when you need it. You don't have to preempt the need and create a repository just in case it's needed, right? Obviously, there are times when you're going to need both, but think about how much effort and time is taken off of the ETL team building pipelines if, for instance, you could build your marts in a virtualized fashion, reading information from the data warehouse rather than instead kind of extending that project exponentially to build now data marts to kind of when you start to drill down into different specific business unit challenges. Real-time information, we all know how important that is to the business user, especially when you're talking about things like product launches, trying to understand how clients are feeling about products, how clients are feeling about improvements to your products. Maybe you've put out some new patches or new features. How do they feel? We need to know that in real time, and that's what virtualization gives you. It gets you straight to the source of the data in a very performant fashion with low impact on the actual back-end data source or system of record. Self-service data service. I think self-service we say as something that's almost like an addition. I strongly believe that this is the norm. We are the users that use data, that want data, are sophisticated. Their questions are sophisticated, and the tools that they have are very sophisticated. So from an IT perspective, we need to give them that flexibility and you get that to a certain extent within your tools, wherever, let's say, for instance, I've picked Tableau, but the problem is it is not as efficient because what virtualization does is give you the finite answer set that you want back, not everything. So then you have to mess with it within your own tool, okay, which is timely and painful depending on the types of users you have. Anyone in IT, anyone who's kind of had to manage in an enterprise, will centralized metadata security and governance is very important. As we said, disparate data sources all over the place. I have to now manage security to each one of those. Well, actually, I'll manage security via the access point, which comes via virtualization, which makes it much more easy to manage and govern. And obviously, the other point about centralized metadata, think about it, is everybody's now reading from the same book. Customer means customer to whoever wants to find out information about customer when they come to the virtualized platform. And the sixth point is, who cares where the data is, right? Certainly the business doesn't. I mean, they understand that the data may be all over the place, but really, when we talk about moving to the cloud, that really benefits the IT team. Now, there are benefits that are extended to the business users, but they don't really care, right? So what Denodo or virtualization gives you is the ability to take that concern away from the client, and also make it easier for you to now tell users how to get their information rather than how to get to an informational repository where your information that you think you're looking for might be there, right? We take that all away. Who cares where it lives? Every organization now has some kind of hybrid infrastructure, right? They've all got on-site assets and systems of records. They've gone out to the cloud. Maybe they've gone Snowflake, or maybe they're a SaaS user and they're a Salesforce user, right? It's still an informational asset that's out there that's not localized. And then extend that with some of the new initiatives we talked about, social media and kind of semantic, sentiment analysis. We need to get that information from maybe data assets that we don't normally go to, right? We have a client that looks at preventative maintenance for its equipment, and it looks at things like the weather to work out if that's going to affect the equipment, so they can set up some kind of preventative maintenance before having to incur heavy warranty charges. So that's an example of not really caring where all the information is. Just bring the information to me when I ask for it. So anyway, let's kind of go on to modern data virtualization. Quickly rush through this. From a modern data virtualization platform, it has to be super efficient, and in some cases be able to deliver data more quickly than direct queries. Because one of the things that Denodo does is every time there's a query, it creates execution plans. So it works out different options for federating that request and picks the best one based on a number of different factors, and that happens under the covers in real time. That's why we can sometimes do better than the direct query. Active data catalog, essential. Data scientists, very important across a number of businesses nowadays. So you have to be able to support those guys. Our platform comes with data science notebooks integrated that's accessible to anyone who wants to use those. We talked about hybrid and cloud. Automation to speed deployment and management. We haven't really talked about the operational side, but we need to be able to control how your solution is deployed, especially when we're talking about enterprise scale solutions. And obviously, single sign-on and fine-grained permissions, that's a given. It should just be expected, From a business perspective, I'm not going to go into details, but the key bullets are, it's got to be simple for the business. It's got to be agile. You can't, this whole thing about give me 2 sprints and I get the data for you. People don't want that anymore. Accessibility, the more options we support, the better. Semantics from the perspective of the consumer, yes, because now this data means something to me because I understand what that field means, and there's a rich description. You can get that all from virtualization, and of course, again, governed self-service. Give the users the freedom, not just to modify their reports, but modify the way the data looks to support their reporting, and do it in a way that's safe and governed and secure, and where not only we can trust that the users are not going to have any challenges, but they trust that we're giving them good quality data as well. IT abstraction, it decouples this whole where does the information store to how do I get the information. Here you go, users, this is the way you get to the data. Don't worry about where it's stored. We have that under control. You know, that's what I would used to say when I was there in operations. Flexibility. We have this use case where we had a client who had their data warehouse in Exadata, and they wanted to migrate to Snowflake. To mitigate the effects to the users, they created an abstraction layer, the virtualization layer on top, and now the users access via the virtualization layer whilst the migration was happening, and all we had to do was tweak, you know, what dates are in Snowflake as opposed to what's still in Exadata, and it was pretty much transparent to the user. We talked about security. We talked about governance as key for IT, especially if you're concerned about security and governance, and of course, accelerated delivery. You know, I remember many years ago, you know, you'd get queries from business users about information, and you might have to create some reports. You might have to create a couple of repositories and reports, and that's, you know, to take a week maybe if you're rushing it. And you know, sometimes you find that the answers that you're giving them aren't really the answer we're looking for, and you have to go back and do the process again. This is just, it's painful. With virtualization, because we're not building, you know, ETL pipelines, and we're not having to go through this kind of rigorous process of migrating data overnight and then doing the QA in the morning, fixing the problems, blah, 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 et cetera, that really does significantly improve the time that, to delivery. And obviously, the less time IT can focus on servicing clients, and more time advising clients, right? Which I think IT should be evolving into now, right? That would make obviously the job for IT a little bit more tolerable, but also empower the user and make them feel that they're more control of their environment. So with that, that's kind of me finished with the kind of the slides. I'm quite happy to take any questions. I know we kind of rushed through it a bit, and if anyone wants me to go back and cover some bits in a little bit more detail, feel free.
Perfect. Thank you so much for your presentation. We do have a few questions.
Sure.
First one is, handle very slow sources.
All right, so slow sources, yeah. So it is a challenge, right? So let's say, for instance, you want to get information from Salesforce. Well, a query from Salesforce is going to be a little bit slower than a query from Oracle. So there are a couple of ways to resolve this. I think the most common way is to cache, to create a cached copy of information from Salesforce, so the queries have gone to the cache. And now with caching, it's really all about the refresh. And with data sources like Salesforce, the refreshes are pretty accurate because every record is timestamped. It may be different for other sources, but in general, caching is a good approach. We have brought in a new feature called Smart Summaries. And basically, you know, we kind of use AI to kind of analyze the types of queries we're having, and when we see kind of some kind of commonality, we can automatically under the covers create, you know, a summary to make that query faster. So we've pre-aggregated and everything, and it's placed on disk somewhere, so that we will automatically go to that that summary first, which, you know, exponentially increases performance. I hope that answers the question.
Yes, absolutely. We do have another question. That question is, how does the solution scale?
Yeah, another good question. horizontally and vertically is the easy one answer, I guess. But yes, we can scale elastically. So we've kind of we can work with like Amazon Elastic Cloud and expand when needed and kind of contract back down when not needed. We can add more cores. We can add more servers to a cluster to kind of help handle lots and lots of requests. And if you've got very, very large requests, increasing the cores will resolve that problem. We can also sit, obviously, we can sit behind a router, and that router can, you know, based on whatever algorithm it has, it can use that algorithm to kind of what's the word? Not federate requests, but moderate where the requests go to, so that we can have a little bit more balance, and we don't have like one instance being completely throttled while the other one's there with, like, you know, only 30% utilization.
Perfect. I see here we have one more question. It's can I deploy in the cloud, and are there any limitations?
Yes, absolutely. In fact, we've actually got some sandboxes in the cloud. So if you want to kind of have a play around with a cloud deployed instance of Denodo, go to our website and follow the yellow brick road, and you'll get there. And we've got these sandboxes you can play in. So you can deploy yourself. We kind of support that with scripts, and we kind of extend it with other capabilities. But yes, cloud, we definitely support the cloud. The only thing we don't have is a version hosted in the cloud that we host. It's, you know, we allow our customers to deploy it into whatever cloud environment they have set up. Perfect. I hope that one works. I hope that answers the question.
Yeah, that wraps up all the questions that we have for this presentation, and this also wraps up our final follow-up series for Big Data and AI Toronto 2020. I want to thank everybody that has participated or joined us for our events. Thank you again to all the presenters for participating today, and please look out for new content and new info on our upcoming Big Data and AI Toronto 2021 event. Again, thank you for everyone for participating, and we'll see you soon.
Thank you, guys. Bye-bye.
Thank you.